So we will continue loading our metal tower. On the last lesson we stopped at the snow loading. We have already finished the loading, snow loading, and now we are going to start um, loading the scheme with the ice load. So you can write in the edit load cases menu, the load ice load. Ice load. So ice load, it is a short-term load. Press apply. But before we'll add this load to our scheme, we need to finish the calculation of the ice load. So ice load is calculated according to this formula, where we need the first of all. Так, интернет что-то у меня вылетел. So okay, let's continue. So to find the ice load, we need made it by using this formula. So here is, we need to put according to your task the thickness of the ice. So each of you, according to the parameters of your task, should apply your own thickness of the ice. So I also will apply it. For instance, my thickness of snow load will be, now I will tell you, it will be equal 10 millimeters. So thickness of my ice load is 10 millimeters. You will accept it according to the last digit of your last name. Oh, first digit according to your last name. First digit. Sorry. So what we'll do next? So we put this thickness in this formula. Next, we will use the several coefficients which take into account the thickness of the ice, which take into account the change of the thickness and so on, and also density of the ice and other coefficients. So generally in this formula we just need to change only one position. It will be first position thickness of the ice. So according to this formula, I change it and accept 10 millimeters for each of the height. So, and the important thing, you see that according to the so the height of the tower is increased, the coefficients are also increased too. It means that the load will be more as our tower will become more in height. So you change this position, first position in each formula according to the height of the tower, and we need to multiply all this 4 digits. So I will use a calculator to make these processes. You also can do the same thing for your own thickness of the ice. So I'll multiply 4 numbers. So I find the 4.3 kilograms for square meter. 4 due to 5 meter. Next position. Multiply 1 multiplied by 6 and 5.4 kilograms. Next, $6.5 kilogram, and the last one, $76. Okay, so what will be next step? So we found the calculated load from the snow in each height of the tower, and now we need to put this calculated load to this table. So this table to find the total load for per meter, погонный метр, for per meter. So we put the finding number in this table. We need to put it with points. Okay. I will change here. And so we put all of that positions we had found in this table. Next one, from 5 to 10 meters. So be attentive when you will put this finding calculated load to the table from 5 to 10. It's not a very quickly processes, not rapidly. It will take from us some time because we need to be very attentive to prevent any mistake in our calculation. Okay, next step. From 10 to 20 meters. 10 to 20. And the last one, between 20 and 30. So the height of our tower is 24 meters. 24 meters. Actually, if I'm not mistaken, but I think, yes, it was, the overall height was 24 meters. Okay, so that's all. Now we can delete the total load for square meters, or per 1 square meter. Then I can make the copy of this table. I will open the new Excel project document, and we'll put this table to this document. So why I need it? Because it will be easy to multiply here. I will just create the formula. When I will show two positions, the section, I will multiply, the size of the section will multiply to the calculated load. Still 5, so I need to make the copy of this. Okay, that's all. Now I can make the copy of total loads and put it at the table in the MS Word. Okay, that's oh, I'm sorry, not it's not all. I need to change the sections because I think it's not my sections according to the task. I have the pipe with the size 133, 121, and 114, and the angles 75, 80, 90, and 100. So 33 right, 21 right. Here I will have not 108, I have 111. Here I have angle 100. In this position I have angle equal 90. I will copy it and put in the next two positions. The next angle is equal to 80. Okay. The last one is 75. 75. That's all. So we have finished finding the load of ice, and I will make the copy of the sections. I will put it into the table. And I will make the copy of the total load, or 1 per meter. Okay, 75, 75, 75, 75, 80, 80, 90, and the 100. 114. Okay, that's all. So we have already found the total load. Now we can start the loading our metal tower in the software LIRA SAPR. So let's begin. First, what we need to select separately each of these sections according to their height. So first we'll select the pipe. It's the main leg or column of our triangular shaped metal tower from 0 point still up to 5 meter, and we'll add the load which are equal to 5.7 kilograms per, per meter. So how I will do it? I will use the option polyfilter. So by using this option, I will select the pipe 133 in diameters, make the fragmentation, we'll use information about nodes, and we'll look at the height. So here is 6 meter, 4.5. Okay, I think 6 meter is will be enough for us. This is height. So I will select all of them. Then I will use loads. In the position load, I will use loads in, on bars, and then I will use uniformly distributed load, second variant. Here is according to Z direction, and I will put this into this window the load which I took from the calculated table for the position for section 133 up to 5 meters. Then I press OK, and I will see that our loading is added, was added. Next, I need to select the pipe from 10 meter from 5 to 10 meter, and I will make the copy of this load. Again, I use the option information about nodes, and I need to click on this node and see information. So the height is 20.5 meters, 10.5. Okay, that's good. It will be enough for us. And I will add, firstly I will select this height. So select the pipe on this height. We'll use again loads, loads on bars using uniformly distributed load. Put the load and press OK. Next, I will select the last sections of this pipe on the height from 10 to 20 meters. And we'll add the loads on them. Okay, so we finished loading the pipes with the section 133. We can restore models, save the model, and start off adding the next load on the section of pipe 121 in the height of 10 to 20 meters. I need to use the option polyfilter. Again, I need to select 21, make the fragmentation, and so I will use the information and see 6.5, 21 meter. So the total height is 21 meter. Okay, so I will select all of them. So approximately 1 meter in height, it's not so matter. Don't pay attention about why we add the load, which should be to up not more than 20 meters. We added it to 25 meters. Not so matter. One meter. And we will use the again polyfilter, and we will show the pipe with the number 114. We'll select it. We select our pipe, then go to the load. We'll took this load. You see that here is height is changed, and now we took the height from 20 to 30 meters, and add the load to this height. So restore models. Next we need to select the equal angles with the size 100 to 100. We use polyfilter. By stiffnesses, we select the 100 to 100 is the sprinkles. Sprinkles, we'll select them, make the fragmentation, and we'll find information 6 meter. Okay, that's enough. 6 meters, that's good. So we'll select this lower spot of the sprinkles, and we'll add the load of snow. Next one is the height from 5 to 10 meters. So let's see the height of these elements. 9 meter, 10.5. That's good. Let's make the copy of the load. We will select So where is these two variants, sprinkles? We have forgot of creating them. So now we need to add them on our script. Or maybe they have another section. Yes, we make a little mistake with the sprinkles. So now I will change the stiffnesses of these elements. Go to the material properties. We'll use the Springle with the Springle characteristics, and we'll add them. So now I will again select them by the stiffnesses. I will delete these loads and will add again. Okay, that's all right. Restore models. Next, we finish the equal angles with size 100. Now we're starting working with 90. So I make the copy of it. I use again filter for elements. Fragmentation. Use the information about nodes. 4.5. Okay, 4.5. 10 meter. So I see that there are no any bars on the height up to 5 meters. There are bars on height from 5 to 10 meters. So I will select them. Then I will use another load from so I need 2 5 from 5 to 10, from 5 to 10. So I need to add it because there are no information about from 5 to 10. I will add the additional, I will make the copy of it. And I will use this load. And I will multiply the size to the calculated load. Multiply to the 486. So it means 4 kilogram, 4.9 kilogram. So I make the copy of it. So load in bars. Okay. And the last elements has the height from 10 to 20 meters. I make the copy of this load and will add that load on the bars. So restore models, okay. So there are no other equal angles with the size 90. So we will use the equal angles with the size 80 from 0 to 5 height. Use filter. Fragmentation. Firstly, I will add it to lowest one. The height is 60 meters. So again, I need to add the information about from 10 to 20 height. We have less than 1 minute, so after maybe 5 minutes we will continue. Okay?
Okay.
I think it will be enough to have a rest 5 minutes.